All right, so today we're going to do operations with radicals. So what we're going to do is we're going to continue on with what we did before, which is simplifying, but we're also going to add in operations like multiplying and adding and subtracting. We'll save division for another day. All right, so let's go back over what we did before from last class. We are going to simplify radicals. So the first one we have here is 3 times the square root of 80. All right, so remember, we want to break down our square roots as much as possible. Any number on the outside stays on the outside, and we'll multiply by any number that we pull out of the radical, whatever we get down. So if we break down 80, right, if you think about it, you got 2 and 40, 2 and 20, 2 and 10, and 2 and 5. And so if you think about it, 2, 2, 2, 2, and 5, we have 4 2s, which means we have two pairs. So if you think about it, 2 times 2, that gives us 1 2 out, and another 2, that gives us another 2 out, so we get 2 times 2, which is 4. So we end up with 3 times 2 times 2 times, and the square root of 5 stays underneath because we can't pull it out. There's no pair to pull it out. So in this case, 3 times 2 times 2, that gives us 12, and we get square root of 5. And that's now we showed you from the last video. All right. There's also other ways to do it, and you'll see me get into this more, is where I don't actually just break it down to the simplest numbers. I actually try to find perfect squares that go into 80. So another way of thinking about this, and I'm going to show you right now, square root of 80, if you think about it, a perfect square that goes into 80 is actually 16 times 5. 16 times 5 is 80. So we know the square root of 16 is 4, and we know the square root of 5 is the square root of 5. So we can do that as well. And we'll get more into this today as we go along. All right, so let's look at the second one here. Second one gives us 4 times the square root of 256. 256 should stand out to you guys. That is a perfect square. So automatically we should know that that is 4 times. Square root of 256 is 16. And then 4 times 16 gives us 64. Again, if you were unsure about the 256, you can break it down. 2, and that's 128. 2 and 64. And at that point, you should go, I know 64, that's 8. But if again, you want to keep going, 2 and 32, 2 and 16, 2 and 8, 2 and 4, and then 2 and 2. And you'll see there's a bunch of 2s. 2s, 2, 2, and then of course that last 2. So 1, 2, 3, 4 sets of 2. 2 times 2 times 2 times 2, which is 16. So I thought about it. 2 times 2 times 2 times 2, 16. All right. Either way you do it, it's fine. You get there. It just takes longer sometimes. All right. Let's try another one here. Try negative 3 times the square root of 36. Again, 36 should stand out to you guys. That is a perfect square. So it's negative 3 times 6, which is negative 18. All right, let's look at the second one here. Negative 2 times the square root of 147. 147. Now, this one might be one to break down. 147. It's a toughie. That's not a number we really deal with. But we do know that 7 goes into it. So if you think about it, 7 and it's 21. And then 21 breaks down to 7 and 3. There we go. We got a pair of 7s. We can pull the 7 out. So we get negative 2 times 7. And then that square root of 3 stays there. So we end up with negative 14 root 3. If you think about it, it's 147 is 49 times 3. All right. Hopefully everyone is comfortable with that. A little review from last class. So the first thing we're going to get into is what is called the product property. These all deal with radicals. And the product property can work both forward and backwards. It's saying that the square root of some number, now this is a times b, and making it a little bit more visual for you guys. The square root of some number is equal to the square root of the different products, different factors of that number. So square root of ab is equal to the square root of a times the square root of b, which is what we've been doing. We've actually been doing this product property the whole time when simplifying, but we just didn't give it to you formally. Square root of a, b, which also means if you take two things and you multiply them together, it can take the square root of a bigger number. So for example, here we have square root of 3 times the square root of 5. Well, neither of them are perfect squares, so we can't reduce any of them, but square root of 3 times square root of 5, based on what the product property tells us, is that we could take the numbers on the radical and multiply them together and get the square root of 15. And that would be my simplified answer. All right, let's look at the second one here. So square root of 9 times 4 square roots of 15. Now, a couple ways to do this. One, you can multiply the numbers together and then simplify, or you can simplify, then multiply. I like to do simplify most of the time before I multiply, just because I know the square root of 9. That's 3. So I know it's 3 times 4 root 15. 15 breaks down to 3 and 5, which is, you can't go anywhere with that. But that's 3 times 4 now. Well, we know that is 12, and the square root of 15 just stays there. Remember, numbers on the outside of a radical cannot multiply to numbers on the inside, and vice versa. Numbers on the inside can't multiply to numbers on the outside. Either they're both inside or they're both on the outside. They don't crisscross. They don't mix match here. All right. So this is why if I simplify 9, I get 3 times 4 root 15. 3 times 4 is 12. If you wanted to, you could have multiplied 9 by 15, and that would have given you 4 times the square root of 135, and then you would have broken down that and ended up 4 times 3 times root 15 again. You would have gotten back to the same place, just taking another step. All right. So that's multiplying and trying to break them apart. We've been doing this the whole time, so what we've previously done was examples of that. All right, adding and subtracting, and we're going to put everything together here. Steps for adding and subtracting. 1 is to simplify each radical to its simplest form. It is always a good idea to simplify each term first before you go ahead and add and subtract, because a lot of times you can't do it. And then the second is you combine like terms, all right? Basically, you want to make sure when you're adding and subtracting things, they have the same radical. If they don't have the same radical, you can't add and subtract them. They have to have the same. Multiplication and division different. You can have different numbers and they multiply together, blah, 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 blah. You knew that from your earlier order of operations day. But for adding and subtracting, you have to have like terms. It's like adding x and x. It has to be, you get 2x. Or can you add x squared and y? And it's no, because they're not alike. You can't add them. So you got to treat radicals like you did variables. Either they are the same or they're completely different, and it doesn't matter. Now, unlike variables, radicals are pretty simple to see because it's square roots or a radical and a number, and the numbers have to be the same. All right, so let's look at the first one here. We have 3 square root of 6 plus 3 root 6. We go, all right, can we simplify a square root of 6? And hopefully the answer you said was no, because it's 2 times 3. Neither of them has a perfect square value in there. But since they are now the same, we see that my radicals are exactly the same, so we're going to add. And when we add, we're only going to add the coefficients, which are the numbers out in front. You can hopefully remember that from the polynomial chapter. All right, so 3 plus 3 gives me 6, and then the square root of 6 just stays root 6. It's like 3x plus 3x, it's 6x. So we get 6 root 6 is my answer. All right. The radical will not change. It's not square root of 12. We're not adding the numbers inside. It's square root of 6. It's like 3x plus 3x. If you did 3x plus 3x, you would get 6x. We're now just changing x to square root of 6. All right, let's look at the second one here. Negative 2 square root of 45 minus 2 root 20. Right off the bat, we see my radicals aren't the same, so we can't just go ahead and add them together. However, we do want to reduce them. So let's take negative 2 root 45. All right, square root of 45 can be broken down to 9 and 5. We know the square root of 9 is 3, so it's negative 2 times 3 times the square root of 5. Minus, go to the second one, 2, and we got square root of 20. All right, that's 4 and 5. Square root of 4, square root of 5. Oh, well, square root of 4 is 2, and square root of 5 stays out of there. All right, so then we get negative 2 times 3, that's negative 6 root 5, minus 2 times 2, which is 4 root 5. Well, now, hey, we got the same base again, same radical. So negative 6 minus 4 will give me negative 10. And square root of 5 again ends up on the back end. And there is my simplified answer, negative 10 root 5. So Break down each one. If you need to, go ahead and get it down to negative 6 root 5. Do the second one, minus 4 root 5. Minus 6 minus 4 is negative 10. All right, let's try a couple more here. All right, concentrate on the first one first here. Square root of 54 plus square root of 54 plus square root of 6. Now, 2 out of 3 are great. We know they're the same. But again, my first rule says let's simplify. Can we simplify square root of 54? You should say, yeah. Numbers that go to 54 is 9 and 6. Well, again, we know the square root of 9. That is 3. 3 comes out. Root 6. Same thing from the next one. So plus 3 root 6 plus square root of 6. 3 root 6, 3 root 6, square root of 6. All right. Look at it. All three of them have the same radical. So we add up our coefficients. It's 3, 3, and hopefully you know, because there's nothing out in front of this, it's an automatic 1. So my answer here becomes 3 plus 1, which is 7, and then the square root of 6. All right. Now, looking at the second problem here. And this is kind of a combination of what we just, the previous two, adding and subtracting, and you multiplying. Now, normal order of operations tells you take what's in the parentheses and see if you can do whatever is in there. You got negative 4 root 6 plus 5. Not much we can do here. However, we are multiplying all this by negative 3 root 3. Well, since we are multiplying, we have to distribute. So we are going to multiply negative 3 root 3 to both the negative 4 root 6 and the plus 5. So again, remember, when we multiply, numbers on the outside to the outside, numbers on the inside. So we do the first one, negative 3 times negative 4 is positive 12, and square root of 3 times square root of 6 is square root of 18. So there's the first part. Then do the second one, plus, or negative 3 times 5 is negative 15, and the square root of 3 remains on the back side. All right. So now, looking at that, we got to say, all right, can we reduce our terms? See if we can combine them at this point. And you get 12 root 18. Well, 12 root 18, we know we can break 18 down to 9 and 2. All right, square root of 9, square root of 2. We know the square root of 9 is 3. So we get 12 times 3 times square root of 2 minus 15 root 3. Do a multiplication, 36 square root of 2 minus 15 root 3. All right, at this point, we've got both our terms to its simplest form, and we look, can we combine them? And the answer is no. Because the radicals are not the same, we can't combine terms. This is not negative or 21 square root of negative 1. That doesn't work. We don't do that. Because they're not like terms, we don't touch them. And so my answer is what you see. It's the 36 root 2 minus 15 root 3. And that's a perfectly acceptable answer. You have to realize it. We can't combine them. And we're not using a calculator here, so we're not trying to get any decimal answers here. This is perfectly simple. This is perfect. This is an absolutely correct answer. So if you think about it, guys, make sure you look and say, hey, do my terms correct? Are my radicals the same? If they are, then we can combine. If they're not, you leave them as a simple expression. All right, let's do another one here. A little bit more. Hopefully you remember this. 2 plus 3 root 3 times 2 plus the square root of 3. All right. Well, in this case, we got to do what? Foil. We got to foil. And so we're going to have to foil. We're going to have to take first, outer, inner, and last. I'm going to do it together. So let's take the first one here. First. 2 times 2. Well, that's 4. That's pretty basic. Let's do the outer. 2 times root 3. Well, that's plus 2 root 3. Do the inner. 3 root 3 times 2 is plus 6 root 3. All right, that's looking good so far. And then let's do last here. 3 root 3 times square root of 3. Well, that's plus 3 root 9. All right, so remember now we've got it to this expression that's an adding and subtracting. All right, so our thing is to simplify every term. Well, the first term can't be simplified. We're good there. Second term is still plus 2 root 3. Third term is 6 root 3. But the last one, square root of 9, we do know that. So this ends up being 3 times 3, or 9. Combine like terms now. All right, so let's look at our like terms here. We have 4 and 9. Well, 4 and 9 together give me 13. And then 2 root 3 and 6 root 3. Those are like terms as well. And that gives me a plus 8 root 3. And I don't see those being like terms, so there is my answer. 13 plus 8 root 3. Right. So that's about as difficult you're going to see those types of problems where we FOIL it out and then you have to combine terms and simplify. And just make sure you're simplifying everything first before you start combining like terms. All right. One more problem here. Now, this one's a little bit more. Now, you'll see that you have this symbol here. You have the symbol right there. That's my plus minus symbol. Plus minus. This means I actually have two different equations. If you think about it, guys, it is 6 plus the square root of 40 divided by 8 and 6 minus the square root of 40 divided by 8. You almost treat it as it's two problems in one. And we use this a lot of times when we're doing square roots, especially solving equations. We'll use this plus minus symbol all the time because it's two different options. I'm not going to worry too much about that yet, but we are going to worry about how to simplify this. Now, you'll notice that all my numbers here are even, 6, 8, and 40. But remember what I told you, numbers on the inside of a radical can never be multiplied, and then also division, because division is multiplication in some sort, can never be divided by a number on the outside. Numbers on the inside and outside don't intermix. So at this point, we can't do anything. We can't just go, oh, they're all divisible by 2 and get 3 plus or minus square root of 20 over 4. It doesn't work that way. All numbers have to be on the outside, all numbers on the inside. So what we need to do here is simplify my 40. Now, numbers that go into 40. All right, perfect squares. I like 4 and 10 because I know the square root of 4 is 2. And square root of 10 doesn't have anything. So what I can do is I'll rewrite this as 6 plus or minus 2 root 10 over 8. Now, everything there has an even number. But I'm not going to touch the radical because, again, numbers on the inside do not mix with numbers on the outside. But I do know that my 6, 2, and 8 all divisible by 2. So at this point, I can divide them. Now, be aware and be careful. Many students like to do this. Oh, that's just 3 over 4, and then that's where they leave their answer. Or they'll do that at the very beginning and go, oh, that's 3 over 4, and then they'll simplify. It doesn't work that way, guys. It doesn't work. Either every term in a division problem is divisible by the number or none of the terms. It's like a GCF. And if you think about it, GCF, do everything have it? And if they do, then you can pull it out or divide it out in this case. If they don't, you can't do it. Now, in this case, they do. So I'm going to go back. I'm going to erase all the bad workings here. And I do notice that my 6, 2, and 8 all divisible by 2. So I can divide each and every one of these by 2. And what that'll give me is 6 divided by 2 is 3. Plus or minus 2 divided by 2 is 1. So I don't have to put it there. If you want to, you can. You can go 1 root 10. I'm not touching the root 10. Again, it's on the inside. I'm not touching it. And then 8, that becomes 4. So my answer in this case ends up being this. 3 plus or minus the square root of 10 all over 4. And that's where we leave it. That's my answer. And that's what it becomes. Hope you learn. I'll get to you next time again.